All right, to go ahead and start this one off here, go ahead and solve these four problems. So they might have two solutions in there, but in the case of the two ones on the right here, we actually have a situation where we have only one solution because the distance between x and 0 is 0 is only, and there's only 0 is the only thing 0 units away. And an absolute value can never equal to a negative number. Distances can't be negative, so that's no solution. All right, go ahead and solve these five inequalities. These five absolute value equations, and then check back and see how you do compared to what I've done. When we're dealing with equations, it doesn't matter so much, that we have whether it's x equals 31 or x equals negative 25 or x equals 31 and x equals negative 25. There are two solutions to this problem here. And with an equation that we don't usually have to make that distinction between the and the or. With the inequalities we do, but not when there's an equation. We don't really, that's not so important. All right, let's have you do three more. Don't forget, you always want to get that absolute value by itself first before you break it up into the two different equations. In this first one up here, the absolute value is not by itself yet. It's being multiplied by a -1. So what we need to do is divide both sides by -1. And when we do that, we get an absolute value equal to a negative number, which is not possible, no solution. This second one looks like, hey, there's going to be no solution, but be careful. We actually have to get the absolute value by itself first, again, by dividing by -1. And when we do that, that actually takes that negative number and makes it positive. This one does have solutions. So now we know that the absolute value of something must be 28, so that something must either be 28 or negative 28, and then we solve those two parts here. This one, we have to remember to get the absolute value by itself first, add 5 to both sides, and then divide by 2 from both sides. Then once again, we have two inequalities, one equal to the +5, one equal to the -5, and we will solve each of those. Go ahead and solve just the top two inequalities here, this one and this one. Just do those two and see what you get. Now we have some absolute value inequalities. This is a little bit different than equation. Let's get a little bit of practice with those. All right, a reminder that when we see the absolute value is written on the left-hand side of the inequality, then the greater symbol will give us an or statement. The less than will give us an and statement. When we have an or statement, we can leave the answer as an or. When there's an and statement, we know that x is greater than some small number and smaller than some big number. It's going to be between those two numbers, and this is a simpler way of writing that. All right, let's think about these things now. We're talking about this distance being greater than a -28. Is a distance ever not greater than -28? So the answer to this one is actually going to be all real numbers. No matter what we put in for x, we know that any distance is always greater than -28. So this one's going to be all real numbers here. This one, when is a distance between something ever going to be less than -28? Well, distances are always positive, so it is never less than -28. This one is going to have no solution. If we didn't see that right away, go ahead and try to solve those algebraically and see what happens. So this first one was a greater sign, so we had an or statement. This one's a less than, we had an and statement. We solved them. We said, okay, x is either, the important with that word is that we have an either. X is either greater than -25, which is all these points here that go on forever in this direction, or x is less than 31, which is all these values that go on forever. And that covers every single value. If you can find me a number that is neither greater than -25 nor less than 31, you could make a lot of money that way, but it's not possible. There is not a single number that doesn't fit into either one of those, or into one of those in there. And this is an either or, so you only have to fit it. That's important that we have to only fit into one of them, and every single one of those does. So this one is actually going to have the answer of all real numbers. And in fact, this is not going to be the final graph. We would have to graph all real numbers, which shows everything. Okay, this other one here, this is an and. So actually, with an and statement, you're finding all the values of x that are both less than negative 25. So you're finding a number that's less than 25, and at the same time, it has to be greater than 31. Not possible. You can't have a number less than negative 25 and greater than 31 at the same time. So that's why this one is going to be the null set. There's no, this one has no solution, not possible. So that's kind of an interesting thing happens when we have an inequality, absolute value inequality with a negative number. We're either going to come up with a situation where we're going to have all real numbers or no solution, depending whether it's greater than that, which is you're never possible, or sorry, it's always possible that your distance is going to be greater than a negative number, and it's never possible that your distance is going to be less than a negative number. Now you're going to have to choose which one of these homeworks that you want to do. In this particular situation here, we have the standard one. You want to challenge yourself a little bit or a little bit more. You decide which one it is. It's not like it's going to be more work. They are just different problems, and the level of difficulty goes up. So decide which level of homework that you would like to do that would fit where you think you're at right now in understanding all of this.